Okay, so here's my slapped together rotor test rig. First thing I want to show you is, and I'll just do it off the computer. Okay, so we started at 14 volts and 5 ohms, and it's drawing about 2.5 amps, which is about what Ohm's law said it would be. Okay, there's the 14 volts. Okay, right here, once it comes in, okay, after an hour of soaking, it heated up from about 65 to about 135, I think it was. We'll find out here in a minute. And current draw dropped to a little over 2.3 amps. And resistance, there it is, 137 degrees Fahrenheit. And resistance declined to 6.5 ohms. So what I thought was real interesting is, okay, I'm going to go ahead, and right here is the TCI trigger magnet, or a crank position sensor magnet. And you can see there's no magnetism. I run that across there, and you can see it grabs it, and it grabs it pretty good. Okay, I'm going to plug it in. Okay, so with it plugged in, first off, let's take this chisel, and it grabs it pretty good. In fact, it takes a hefty pull to pull it loose from there. I've got the rotor clamped down to the bench. Here's what I thought was interesting. Okay, the copper rings block about 90% of the magnetism, 99% of the magnetism's coming through, and you can still feel the TCI sensor grabbing it. If you get on either side of it, you can feel a little bit of the magnetism pushing away, but when you're dead on it, it's still a fairly strong magnet. So that's how the TCI is sensing the magnet that's sitting in a huge magnetic field, because the copper windings are blocking most of that. I thought that was interesting.